Very good. Anyway, kidney failure. Let me remind you, as the blood leaves the heart by way of the aorta, goes over the aortic arch, begins to descend, and we have the thoracic portion. Right as we begin the abdominal is where blood flow from that artery is meeting the kidneys. Therefore, kidney blood flow is extreme. And I mean that. We'll talk about it when we get to that chapter. The blood flow through the kidneys is just astronomical because their job is filtering. Okay? So kidney failure would definitely affect these principles that are governing the flow and the pressure, both. Edema, we're going to see a little bit more of that as we look at the capillary bed. Aneurysms, where there's a stretching in an artery somewhere, okay, that'll impede flow, affect pressure. In any of these cases, blood pressure most likely is going to rise. Now, here's the problem. If blood pressure increases, and I already have something that is affecting the flow and the pressure already, and I increase the blood pressure, I'm increasing the flow, I'm going to increase more blood pressure, increase more flow, and I still got stuff impeding the flow. Does that make sense? This is not a healthy condition, okay? And it does, you know, over time, end up creating issues with blood pressure. Under normal circumstances, where you don't have any of these physical conditions, blood pressure goes up and down in the body all the time, okay? The body meets that demand. However, there are cases where blood pressure becomes chronic, and that's going to be a case where they consider at rest. Your blood pressure is higher than 140 over 90. When those numbers kind of go really high, doctors will begin to get concerned. If you have like that, you know, the high blood pressure, you go to the doctor and they check it, and then they check it again before you leave, and it's still a little high. They'll probably be like, well, you know, why don't you come back next week and let's check this again? And you go back and maybe it's up again. Well, they might start getting a little concerned. A lot of times, put you on blood pressure medications to try to help lower the blood pressure. All right. In some cases, it can just simply be chronic. No matter what happens, the person just seems to have blood pressure that just won't go down. And they can try medicine after medicine, all this sort of stuff. It ends up leading to lots of health problems because of this blood flow now being affected to all areas of the body. Hypotension, low blood pressure. The problem with that is you're not getting blood flow to the tissues, and therefore they're not getting nutrients they need and getting rid of waste. So once again, it's a very, if it becomes chronic, then they can also try medications to get your blood pressure up and see if they can't get it to be somewhere near normal numbers. Blood pressure is getting too high, kind of run the risk of heart attacks and that sort of thing. Kidney issues, a lot of it will affect the eyes because of the blood flow being too great for the arteries in the eyes. There's just so many things that can go wrong. When we look at blood pressure getting determined, we've already mentioned cardiac output and blood volume. If you remember, cardiac output, what's the amount of blood? Blood volume gets regulated a lot by our kidneys. We'll get more into that when we get into that chapter. When we're looking at the vessels for this chapter, once again, let's remember the vessels are tubular. That's what they are. They are a system of tubes. Therefore, they have the lumen that the blood moves. Think about this structure, okay? Because we've got the vessels that are peripheral to the heart, any type of resistance, anything that will oppose the flow is peripheral resistance, because we're on the periphery of the body. We're on the periphery away from the heart. A big one, blood viscosity. How thick? This is where the importance of drinking the water comes into play. If it's not properly hydrated, if other conditions might be present, the blood thickens. When the blood thickens, we're not going to get the proper work from the heart. Therefore, we're not going to get the proper flow to the tissues, and things can not go very pretty. What's the length of the vessel? Okay, do I have a vessel that's got to run the entire length of my leg? Do I have one that's got to run the entire length of my arm? What is the length of that vessel that the blood has to travel? The longer the vessel is, the more friction it will encounter. It's a tube. And if you've got this long tube, and if you've got blood, which has lots of components in it, red blood cells, white blood cells, proteins, electrolytes, leukocytes, it's got a ton of stuff in it, all right? So the longer that vessel might be, the pressure as well as the flow declines with distance. For example, blood leaving the heart. Let's go with that good old norm of 120/80. However, as it continues to flow, 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 and think about a capillary bed. Do you think the pressure at that capillary bed is still 120/80? No. That blood has traveled. As it has traveled, my pressure has definitely decreased. Does that make sense? All right. What is the radius? One thing that we have tried, that the book tries to show, the lab manual tries to show, I've tried to kind of explain it in the arteries and the veins. We have arteries that start big and continue to get smaller until we get to that capillary bed where it's the smallest, and then it meets the smallest vein, and as it travels back to the heart, the vessels get bigger. Okay? So you get big, medium, small, small, medium, big, okay, for this flow. That means that their radius, that tube, is either going to be a larger radius or a smaller radius. Wow. The most effect. But also the most adjustable. Wonder what that's going to mean. In our vessels, they're going to have the ability to either stay widened or constrict. Vaso refers to vessels. So therefore, vasoconstriction, vasodilation. They have smooth muscle. Therefore, this is being controlled by my autonomic nervous system. Being able to widen and narrow is vasomotion. It's being controlled by an area in my primitive region of my brain. Under normal circumstances, the flow through this tube would be laminar. Have you heard that term before? Laminar means laminar means in layers, almost like sheets of something. So that means in this tube, it almost looks like as the blood flows, there's one layer, another layer, third layer, fourth layer, as it flows through the tube. It flows fastest right through the middle of the tube because the most resistance that we're going to get is the walls of the vessel themselves. So the layer closest to the wall of the vessel moves slow. The next layer from that, a little bit faster, until we get to the very middle of the vessel where it flows the fastest. So our blood flow is laminar. In a large vessel, this is great. But wait a minute, I just mentioned we start out large, go to medium, get to small. Small goes to medium, gets to big. What's going to happen to the flow of that laminar when I'm at the capillary beds where the radius is the smallest? Why, Marlisha?
It's just not that one, so that one at a time.
What would be the importance of having it go that slow? Transfer. Movement of materials. I get no movement of materials in the large to the medium until I get to that capillary bed, and then I have no movement once it leaves the little going to medium back to large. The only place movement occurs is at the capillaries. If it's occurring somewhere else, trust me, something's wrong. Severely. What did I just tell you guys? In the grand scheme of things, what does this mean?